And we're jumping straight in with the very blueprint of modern knowledge, starting with how we organize and pass on what we learn.
Education.
Education. So if you look at a university today, the way research is done, the way it's verified, you're saying it owes a massive debt to institutions that were built in cities like Baghdad or Cairo or Cordoba.
A structural debt. It's the model they created.
Tell us a bit more about those early institutions, like the House of Wisdom. What made them so different from, say, earlier schools of thought?
Well, the key difference was systematization and a move towards secular knowledge.
Okay.
Before, learning centers might have been attached to a temple or a specific court. These new institutions, they developed formal, standardized systems, structured teaching, massive libraries, and maybe the most critical piece, they formalized the intellectual process itself.
You mean like peer review?
Exactly.
Wow.
Peer review. Huge translation efforts that took scattered individual insights and turned them into a shared, accessible body of knowledge for everyone.
So you're saying the foundation of the modern university, the library system, the curriculum, the research hub, that wasn't a European invention. It was really established in places like Baghdad.
Precisely. That model, the lecture halls, the idea of a central institution for intellectual pursuit, that's the inheritance. It laid the groundwork for the entire global academic tradition we have today.
Okay, so moving from the system of learning to the actual language of science, the numbers themselves. Topic 2, the modern 0 to 9 number system.
This might be the single most important mathematical concept for the modern world. Seriously.
Why? I mean, other systems existed?
They did, but they were so cumbersome. You know, like Roman numerals. Imagine trying to multiply, I don't know, CXL33 by LE9X.
No, thank you. It sounds agonizing.
It's nearly impossible for complex engineering because they lack positional value. What Islamic mathematicians championed was the decimal system. The value of a digit is determined by its place.
And 0.
And the revolutionary concept of 0 as a placeholder. That combination made calculations exponentially faster, simpler, and way less prone to error.
This isn't just for accounting, is it? A
Yeah.
positional system with a 0. That sounds like the absolute prerequisite for digital technology.
It is the backbone. It is. Modern finance engineering, sure. But without 0 as a placeholder, a thing that represents both a value and a lack of value, binary code is impossible.
So all modern computing.
All of it. Every single bit of data processed by the device you're listening on right now traces back to that elegant breakthrough.
Wow. That connection leads us straight into our next topics, algebra and algorithms. Let's start with algebra. If ancient civilizations already had, advanced geometry, why invent a whole new language? Why did Al-Khwarizmi need to formalize algebra?
That is a fantastic question.
Yeah.
Because geometry could solve specific, concrete problems. The size of a field, the angle of a building.
Right, tangible things.
Exactly. Algebra, as Al-Khwarizmi codified it, moved math from solving puzzles about things to creating general rules about relationships. He created a universal language for abstract problem solving.
So he gave future scientists a power tool that works on any scale.
He did, and that power tool is the fundamental language for all modern science, technology, economics.
Yeah.
But his influence goes even deeper into your daily life. We have to talk about algorithms.
Right, algorithms. The word itself comes from his name, from Al-Khwarizmi.
It does. The concept here is defining math as a repeatable process, a series of steps anyone can follow to get a predictable result.
So what does that mean for you listening right now?
It means everything. Think about your phone. Algorithms run every search you make, they curate your social media, they train AI. Every single operation your device performs is running on principles described in those texts. It's the conceptual ancestor of all modern software.
That's a huge leap, and it moves us from abstract math to securing information. Our next topic is so critical for modern life: cryptography. Code breaking.
And your ability to send a secure message traces directly back to Al-Kindi in the 9th century.
What's so fascinating to me is that one of the earliest applications of this math was for communication security. How did he even approach code breaking?
He invented frequency analysis. Before him, like you said, it was just trial and error.
Guesswork.
Pure guesswork. Al-Kindi realized that in any language, certain letters appear more often than others, like E in English. By counting the letters in a coded message, he could use statistics to figure out the underlying structure and crack the cipher.
Without needing the key.
Without the key, he applied statistics to communication.
A brilliant insight. It's the combination of math and statistics that creates security.
Exactly. And that framework paved the way for every secure message you send today. Online banking, encrypted messaging. It's all fundamentally built on that early statistical approach.
Speaking of things that revolutionized communication, let's talk about sight itself, topic 6, optics and the camera. Ibn al-Haytham completely changed how we understand light and vision.
He really did. For centuries, the Greek idea was that vision worked by rays shooting out from the eye.
Right.
Through incredibly careful experiments with the camera obscura, a dark room with a pinhole, he proved that light travels in straight lines and enters the eye.
It seems so basic now, but that was a revolutionary
A
shift.
total shift in physics and perception. And his work with that pinhole camera, the camera obscura, developed the foundational principles that guide the entire field of optics today.
So all modern cameras.
Absolutely. Modern cameras, projectors, medical imaging like endoscopes, even VR headsets, they all rely on those discoveries about how light behaves and how an image is formed.
Okay, we've covered some pretty abstract knowledge. Let's shift to something intensely practical.
Yeah.
Mechanical engineering and automation. We're talking about innovators like Al-Jazari.
Yes, and the Banu Musa brothers. Their work shows this early, really sophisticated commitment to automation. They weren't just building little toys. They were solving real-world problems with complex machines.
Al-Jazari designed machines that were programmable. That just sounds incredible for the 12th century.
It is, conceptually. I mean, take his famous elephant clock. It used water pressure and gears and automata to mark the hours. Some of his devices had what we'd now call a feedback loop.
They could adjust themselves.
In a way, yes. They adjust their function based on water flow, which is a conceptual ancestor of modern control systems. His work gave us literal blueprints for things like crankshafts and complex gearing.
So their work is the great-great-grandfather of modern robotics and industrial machinery.
That's a great way to put it. The very idea of a machine executing a complex, pre-programmed set of tasks without a human constantly intervening, that intellectual path starts right there.
Now, something just as fundamental. Human health. Topic 8. Hospitals and medical systems. The modern hospital, you're saying, has its roots in the public hospitals, or by Maristans, of the Golden Age.
It absolutely does. And these weren't just places to get better. They were some of the first dedicated secular public health centers. And crucially, they were meticulously organized.
How so? How was it different from what came before?
Well, for one, they had specialized wards for different diseases, a concept we totally take for granted. They had trained staff, pharmacies on site preparing medicine, and, critically, they kept medical records.
Wow.
And they also functioned as teaching hospitals. Physicians would pass knowledge to students through hands-on practical application.
That sounds exactly like a teaching hospital today.
It is the enduring model. Any major medical center you see today follows that precise structure. Specialized training, documentation, patient records. It's a systemic approach to health that has lasted for centuries.
Okay, before we get to our last point on global navigation, we have to touch on a cultural contribution, one that dramatically shapes how you work and socialize every day. Topic 9. Coffee.
A lighter topic, maybe, but its influence is undeniable. Coffee came out of Yemen, and it spread through the Islamic world, initially used by Sufi mystics to stay awake for prayers.
And what happened when it went public?
The coffee houses, or kaveh-khana, became these vibrant public centers. They weren't just for drinking. They were places for conversation, poetry, scholarly debate. They sort of democratized intellectual exchange.
A third space.
A third space, exactly, outside the home or the workplace, where people could share and refine ideas.
That sounds like the direct blueprint for the European Enlightenment coffee houses and, modern startup culture.
Absolutely. That whole culture of a study space, a creative cafe, the hub of coffee-fueled productivity, that is the legacy. It literally changed the tempo of work and intellectual life.
Okay, finally. Let's talk about how we move across the planet, our last contribution, navigation, mapping, and the foundations of GPS.
Right. To run an empire that spanned continents, you needed incredible astronomical and mathematical skill, especially for trade. So Islamic astronomers, they refined the astrolabe.
The handheld device that let you measure your position using the stars.
Exactly. It's like an early scientific calculator.
Yeah.
But to make it work, they had to massively advance trigonometry. They moved beyond simple flat geometry to spherical trigonometry, which is much more complex.
To map a curved Earth.
To map a curved Earth. They use it to create incredibly accurate maps and determine latitude and longitude.
And here's the connection I find so amazing. The mathematical principles they developed. That's what we use today.
It's the entire foundation of today's navigation systems. GPS works by trilateration, calculating your exact spot on Earth based on the angles from multiple satellites.
Right.
That mathematical framework. using angular measurement to find a point on a sphere. The basis for that methodology was established by these scholars.
That is just a phenomenal collection of contributions. When you put all 10 of these together, it's so clear that the Islamic Golden Age didn't just inherit knowledge, it transformed it.
It really did. It created systematic models for education, the mathematical engine for the digital age, a model for public health, the concepts behind automation, and the tools for global navigation.
And the beauty of this legacy is how immediate it is, how it's woven into the very fabric of your life today.
Just think about it for a second. Every secure, encrypted message you send,
Right.
every GPS search you run to find your way,
Mm-hmm.
every photo you snap on your phone, even, yes, every cup of coffee you drink to power a late-night project.
They all trace a part of their story, their DNA, back to this extraordinary period of human creativity. It's a powerful reminder that progress isn't usually some sudden invention.
No, it's a continuous exploration of knowledge built by brilliant minds across history. And they created systems that last long after their original context is gone. You are, in effect, a beneficiary of their intellectual investment every single day.